Yes, folks, we are back with the remaining group of problems in that question number 2, where they tell us that we took the problem number 1 and 2, they both modulus problems. So that we did in a particular logic. Now these are by and large 2 problems on trigonometry, and then one is a polynomial. So let's see now how we can do this problem. Here we have got the third problem. H of x is sine 2x plus 5. Now we all know that sine of any function has its a range always lying between -1 and 1. Sine of any value is always between -1 and 1. That idea we are going to take care of, and that's how we are going to solve and get the uh, minimum and maximum values of h of x. So let's try to start with that. We know that sine 2x will always lie between -1 and +1. So if that is the case, in order to reach to the function, we are going to add 5 everywhere. So when we add 5, we'll get 4 here. This will be function and this will be 6. So you are having the h of x value between 4 and 6. That's it. So that's what allows you to tell the maximum and minimum value. So the maximum value of this function is 6 and the minimum value is 4. It's very clear. Very easily we could get it just by using the logic that sine value is always between 1 and -1. Same idea we are going to use in the next problem also, which says that f of x is sine 4x plus 3. So same idea we can use here, since we know that sine is always between -1 and 1. So we will use that idea. We know that sine of 4x over here, because it's 4x, will always lie between -1 and +1. Since the function has got a +3, we will add 3 on all sides. So it's -1 plus 3 sine 4x plus 3 and 1 plus 3. So here it's 2 sine 4x plus 3 and 4. Now luckily for you, this sine 4x plus 3 is lying between 2 and 4. Because it's lying between 2 and 4, even if you take the modulus, it doesn't matter, because anyhow it's lying between positive values. So if we try to look at the modulus of the entire expression, it's the same. Sine 4x plus 3. So it's like 2 less than or equal to f of x less than or equal to 4. That helps us to give us the maximum and minimum value. The maximum value is 4 and the minimum value is 2. That's about it. So that's how we are able to get these answers for the sub question 4. Now we'll go for sub question 5, which is actually a polynomial function and quite simple, x plus 1. And it says that the value of x is in the open interval -1 and 1. So here it's very clear to us that x is lying between -1 and 1. Please note the sign, because it's open interval, we can only take it like this. Now function is x plus 1, so necessarily you have to get a +1. So adding 1 everywhere. So when you add 1, we are getting 0 less than h of x less than 2. Now those h of x is lying between 0 and 2, because it is not lesser than or equal to over here, because that symbol is not there. We are not able to tell the maximum and minimum value. We are able to predict the maximum and minimum value only if that symbol that is there should be less than or equal to. Then only we are able to predict the maximum and minimum value. So though we get this can be called as a bound. It's a bound. You know the lower bound and you know the upper bound, but we cannot tell the maximum and minimum value. So that we will write over here, that neither maximum nor minimum value exist. Why? Because it's not lesser than or equal to. That's about it. Very simple application. As I told you, not so important from the exam point of view. We don't see it appearing many times in the exam, but understanding why is important. And by chance, if it comes in an MCQ, you should know in what way it can twist and turn and how you can get your answer. So that's about this. As we always tell, please popularize channel amongst your friends and see that there is lots and lots of subscribers come turning in. Thank you.